In Unit 3, we're going to study energy. In Unit 3A1, all we're going to do is introduce what energy is and its transformations. A lot of these basics are going to carry through some of the calculations that we do in this unit, or most of the calculations, I should say. Energy is the ability to do work, and what you're going to hear a lot in this term, in this activity, is the word energy and the word work, and they're often interchangeable because they're used in each other's definitions. So, as far as the formula goes, work is equal to force times distance. If you push on a rock and it does not move, by definition, you are not doing work. So you can exert a force on something, but you are not doing work until it moves a distance. Now, in the next video, what we're going to do is we're going to introduce two very important formulas for energy, especially mechanical energy. So we're going to do one for kinetic energy and one for potential energy, but we'll get to that in the next video. What you're going to see is forces in newtons, displacement or distances in meters, and what we call a Newton meter is joules. Now, here's the tough part. If I told you to go outside and I asked you what the weather was like outside, you would go outside, you could see the temperature's 24, and you would know it's a nice day out. If I say joules, you have no idea what that means. So if you want to take a look at 1 joule of energy, think of taking a 2 kilogram weight and lifting it up by about a meter. That's a joule. So the hard part here is trying to wrap your head around these units that we're going to be using. Now, what you're going to see is there's many forms of energy. So there's 3 main themes here that I want to talk about. One is there's many forms of energy. Just some examples: sound, thermal, which is heat, electrical, nuclear, chemical, gravitational. And these are usually categorized as kinetic or potential. And in this activity today, they are going to use the terms kinetic and potential. Don't worry too much about those terms right now, because we will take care of those in the next video. Okay, now another thing that they talk about in this activity is that energy is conserved. So if we have 100 kilojoules of thermal energy and we transfer the energy into electrical, and by the way, that's another theme here. There's not just many forms of energy, but they can be transferred between each other. So we can transfer heat energy into electrical. And then they say that that energy is conserved. Well, what does conserved means? It means the energy before is equal to the energy after. And you might look at this and you go, wait, those numbers are not equal. There's no conservation of energy here. Well, you have to remember, every time that you do an energy transformation, some of the energy is going to transfer into other forms of energy. So as that transformation's occurring and you hear a sound, some of that energy is going off as sound. So then another 10 kilojoules has to be transformed into another form of energy, whatever that may be. But whatever you start with must be what you end up with whenever you're doing calculations in energy. We do not lose energy within a closed system. And once again, that's something that we're going to define a little more closely later on. Now, you are going to be doing an activity today, Unit 3, Activity 1, Assignment 3, and what you're going to be researching is renewable forms of energy versus non-renewable forms of energy. This is really big in our modern world. So we've been using a lot of non-renewable forms of energy, and that means we're going to run out of those. So we need things that can be produced over and over and over again. Examples there would be sun or wind. So if you look in this activity or assignment, they're going to tell you different forms of renewable and non-renewable and the type of research they want you to do on those. You just got to make a table, hand it into the Dropbox.